Where's Andy?
No, it's in the fourth row.
Yeah. Did you say something, Tomas?
25.
Oh, no.
25.
One, minus one. Yes.
Alright. Next step is that we have Jaden, Darlene, Faden, Andy, Samaria's not here.
No, but I don't know what I will.
Tiffany, Ashanta, Celia, Jonathan, Eduardo, Jay, Steve, and Vladimir, person today. Sophie's here, Marissa's not here. Tomas, Abraham is here. Xavier is here. And Freedom.
I know you did.
Alright, where are we at in the oven? Number three.
Number 3. Is
Okay.
molecular formula, is that after our reactions?
No, that's after you find the empirical. Gotta find the empirical first and then use that 48 to find the molecular.
You change it to moles. No, it's just aggressive. Yeah, it's just a mole. I don't remember So if it's diatomic,
So if it's diatomic what?
we have to, like for mole, 75 grams, we divide.
No, you're not gonna put diatomics on empirical formulas because you're trying to figure out what the subscript is, so you don't want to predetermine that.
Okay.
Oh crap, I forgot. How about it?
Gotta find the empirical first.
Oh my
Look. I do that sometimes. You know, I go there, I'm like, why is there? That's okay. Let me ask you last week, put there Google stuff. And I did all of it.
So we gotta get rid of that. So like, this is 48. That's all good. Oh, was that one day?
And you can break them all.
Huh?
Yeah.
What about?
I appreciate it.
All right, can we talk about what you got? So in the first, well, we'll spend a half hour on the opening.
Well, you gotta remember this is.
Well, it is review, but,
Alright.
all right, so on the first one, we're almost done.
I'm on the last one now.
Bible age.
Okay, well, do it quietly.
That's all.
And then you divide.
I thought my grandma goes,
Small
she's looking at the
number, right?
diet board and then we'll do it quietly.
What?
You divide all of them by the smallest number.
Yes.
Yes.
Hey.
I forgot how to do
Page 4.
So wait.
And then we.
No, let's do
Oh, I got it.
So we don't use diatomics with this one?
No, not with an empirical formula, because you're trying to find the subscript, and you don't want to predetermine what they are.
I'm finished with one.
Okay? Are we coming over there, Tiffany?
Good. What is the medicine? I need a table of
AP testing. Started today. I don't remember which one. Which AP test is today?
Sci-fi.
There you go.
Okay. Should read my emails. Stop worrying about it. You're not a friend.
Okay, you're good.
I'm good?
Because 48 is like.
All right, so number one, how do we write the name of lead for oxide? Now, Tomas asked me what the symbol was and I wouldn't tell him. Now, at this point in the semester, I really expect y'all to know them or to look them up. Now, you don't get an oxidation sheet at this point. We're going to do some more formula writing towards the end of the semester because we need to learn how to do ionic reactions and how to write states. So, if you don't know how to find them on a periodic table, you need to learn how to do that. You do not get an oxidation sheet from this point forward. So, lead is Pb. The Roman numeral 4 means what? That's its oxidation number, right? And oxide is O. IDE tells you it's binary. There's only two elements. What's oxide's oxidation number? Now, those two things together should tell you what's going to happen when it crisscrosses. It's going to need to simplify. So when you break that 2 and that 4 down, they're able to be reduced, right? So since they're able to be reduced, you should know automatically that that 2 and 4 are going to reduce into a 1 and a 2. Okay? So 1 and 2. And we're going to not write that 1, I hope. What? We're on day 65 today. So what's that? 13 weeks into the semester. All right. The second one, how do we write the name? Manganese. What is this? Sulfate. Does it need a Roman numeral?
Yes.
It does. Now, how are you going to know if you need a Roman numeral? Group 1, Group 2, aluminum, zinc, whoops, my end stopped there, and silver have no Roman numerals. Okay, that's it. So, if you're in group 1 on the periodic table, group 2 on the periodic table, and those 3 elements. Those are the only things on the periodic table that do not have a Roman number. Everything else on the periodic table has a Roman number. Okay? You don't know it, write it down. Because you're going to have to name something on that exam. And you're going to have to know whether or not it needs a Roman number. So, when you look at manganese, is manganese in group 1? No. Where's it at? It's in the D block. So, the only things that are in the D block are these 2 elements. Is one of them manganese?
No.
It needs a Roman number. Okay? That's why you put it there.
Why does it not need it?
What?
Why don't they need it?
Because those elements only have one singular oxidation number. Okay? And we don't use a Roman number if you only have one number. And those are the only elements that are going to have one number. So if you look at your old oxidation sheet, everybody that's in group 1 only had one number. Everybody that's in group 2 only had one number. These 3 only had one number. Everybody else pretty much has more than one number. Okay? Those are the ones they're going to expect you to know for the exam. Everybody got it? All right, writing an equation. This should be a pretty easy task for us. How do we write aluminum? Is it diatomic?
No.
Then we just write Al. Plus hydrochloric acid. What do we know about hydrochloric acid? HCl. It's one of the 4 I made you memorize. All right? What kind of reaction is this?
What kind
Really?
of reaction is it?
How'd you know that? Huh?
One of the elements is switched up to the other.
It's an element plus a what? That's why it's single displacement. Okay? Now, I even told you what it made. But on the exam, they might not tell you what it made. Okay? So, how would you do this if I didn't tell you what it made?
The first one in the compound is the positive.
That's right. You'd switch the what to?
Negative.
The who and the who?
No, the positive.
The positive and the positive. Okay, just check it. All right, so instead we made aluminum chloride. How do I write aluminum chloride? AlCl. And what do we know about aluminum? And what do we know about chlorine? So we bring our, and then plus hydrogen. How do I write hydrogen? H2. Is it balanced? No. So what are we going to do to balance? All right. Most people look at it and they go, balance here. All right. Well, that won't work with the H. And then they go, well, I can put a 2 there. Well, that won't balance with the Cl. So most people pretty quickly find out 2 and 3 are not going to work. So you need to raise that to a 6, right? So I made 6 Cls. So to get 6 Cls, we put a 2. 2 aluminums, we need a 2. We have 6 H's, so we need a 3. Everybody okay with that? Andy?
Will the exam be all multiple choice?
Yes. 45 multiple choice questions. All right. And the last one is math. Okay. So it asks for an empirical formula, and I gave you 75 and 25. 75 grams of C and 25 grams of H. What do I do with these 2 numbers? Change them to what? Moles. So 75 grams of C and a chart. 12. 1 mole. What do I get when I divide?
6.35
All right. And then 25 grams of H. And I'm just going to put 1 gram because I'm lazy. All right. So what do I do with these 2 things?
You divide it by 6.25.
Divide by the smallest number, which would be the 6.25, and we get 1. Divide by 6.25, and we get 4. Now, once you get that, what's the empirical formula?
CH4.
CH4. Now, that's the empirical formula. Now we need to find the molecular formula. That's where that number of 48 comes in. So, what am I going to do with the 48?
48 divided by that. Like
No, I didn't.
mass or whatnot.
We're going to take the 48 and do what?
Divided by the mass.
Divide by the mass we add up. So, what am I going to add up?
C1 and then H1.
All right, so there's how many C's,
One,
how many H's.
4.
So that's where Tomas is getting 12 and 4, because he said 4 times 1 is 4. 1 times 12 is 12, so we get 16. So 48 divided by 16 is 3. So the formula was originally reduced by a 3. So 3 times CH4 will give us what? Yes. That's your molecular formula. Questions about how to do any of those?
No.
Like I said, I picked something older for us to review in the opening today because we're not doing a traditional benchmark tomorrow. We're doing our gas law test.
Can you go back to the question?
Everybody have what they want off of this? All right. Here's the questions. All right. Does anyone have a question on anything from the gas law review sheet that I told you to work on over the weekend? Because if you have a question, I'll be glad to answer it. If you don't, that's okay too.
What is that about? What is that about?
16,
She's like,
16, 17, 18.
You want to pick one of those? They're all the same.
Well, we'll just do 17, since they don't have.
Did you work either of those? So you just want me to do
you
one?
said just picking a number. So
Okay, well, Sophie's doing the same thing because she hasn't worked one either. So y'all agree on one, 16 or 17. I mean, I wouldn't care if y'all,
I didn't.
Okay.
You didn't take all that.
my point is, if y'all actually had some work and we were correcting it, I'd do both. But y'all didn't do either one of them, so just agree on which one you want me to work. Because I don't need the practice. I know, which is why I gave it to you. No, we're doing something new today. You had practice for the weekend.
You'll put new stuff in our head.
So that's
Yes,
all,
I am.
that's what's all gonna be on the test?
Yeah,
Oh.
the multiple choice of what's on this. So if you look at number 17, okay, it says potassium chlorate, KClO3 decomposes. Okay, so KClO3 decomposes into what? It says what volume of oxygen. And I even wrote in parentheses potassium chloride is the other product. So oxygen plus potassium chloride. So is it balanced? No, there's 3 O's and 2 O's. So I'm going to put a 3 there and a 2 there, which means I need a 2 there. So I have a mass and it asks me for a volume. So can I do a volume-volume ratio if they give me a mass or grams and I need a volume? No. The only time on the test bar I can just draw a chart is when they give me a liters and they want a liters for an answer. If they do that, I can just draw a chart and be done. Okay? Or if they give me a milliliters and they want a milliliters, then I can draw a chart and be finished. But I can't do it when they give me a what? They gave me 12.8 grams and they want me to finish with the liters. I can't do that. I got to do a what? The little PV equals NRT. Okay?
So you have to do that and then the little liter thing?
Yep.
Oh my God, that's extra.
I'm sorry. That's why it's 10 points. There's a lot of extra points attached. All right. So in that one, it says 38 degrees Celsius. And we know R is 0.0821. We know pressure is 575 millimeters of mercury. And I gave you a mass of 12.8 KClO3. And I want to know the liters of oxygen. Okay? So when I go to solve this, all right, first thing I need is what? That's the first thing I do. I get those things changed up to the right units. So 575 divided by 760 is 0.75. And 38 plus 273 is 311. Okay? And this one, grams to moles, think that one's 122. Do I have that written down? Yep, 122. So 12.8 divided 122, 0.104. All right, so now I'm ready to do what?
Solve.
Yep, PV equals nRT. Pressure is 0.75. Volume we don't know. N is 0.104. 0.0821. And 311. So volume equals 0.104 times 0.0821 times 311 divided by 0.75. I get 3.5. Now, that's liters of what? Liters of what we started with, which is KClO3. So I need to convert from liters of KClO3 to liters of what that asks me for, which is oxygen. Where do the numbers come from to do that?
The coefficient.
Yep. So oxygen has a 3 and KClO3 has a 2. So 3.5 times 2, times 3 divided by 2. I have 5.3 liters of O2. Anybody else? Question? Huh? Anything?
No.
No? All right. So you have a multiple choice sheet to help you with the 10 multiple choice questions. And you have, what was that? 18 math questions to help you with the 11 word problems on the test. Okay? It is possible that this will be the last test. Typically, I give one more. We'll just see how we're doing time-wise as to whether I do. Okay? So, there are no more test corrections this quarter. Okay? If you make a 12, come see me if you flunk it and have to take it again. Okay? Hopefully, there will not be many of y'all. All right? Now, I have one or two who are not going to make it. Now, this is the reality of where we are. They're in third period. I don't anticipate anyone in here not making it. But I do have a few in third who are not going to make it. Every year I try hard to have no one fail.
How many people do you usually have?
Huh?
How many people usually fail?
Last semester it was 8. I think this semester will be less. Some of them are going to fail on days, so they'll have an opportunity to make up their time in the summer.
Got any seniors in the third?
Yes. I have 1 in here, and I have 3 in third.
Is one of those seniors the one who's going to fail?
I know one of them who you've already talking about.
I hope not.
Yeah, call them out.
Keep calling out stuff.
Might as well call them out.
Nope, won't do it. All right.
You keep talking like that, we're gonna figure it out.
My grade is like 70
Right.
Now, we're going to start a new topic today. All right. So this topic is really an odd hodgepodge of topics. We're going to start with comparing solids, liquids, and gases. And we're going to go through phase changes and phase diagrams. We're going to hit equilibrium and thermodynamics before we get to the point that I'm going to be willing to test. There will be a large number of quizzes between here and the test. Some of them will be multiple choice. Some of them will be free response. Some of you will wish that I would have given free response instead of multiple choice. All right. Most people don't like my multiple choice quizzes. The free response are easier. So I guess for a title, okay, for this one, start it with solids, liquids, and gases. Okay, because we're going to start by comparing the 3. And then we'll move on from there. Have I what? No, I have not. Probably when it comes out. I won't go to the theater because I'm cheap. It won't bother me because I probably won't remember it.
A lot of them died.
Oh, really?
They just disintegrated in the end.
Hey, bro, shut up.
Alright, buddy. Come on, man. I told you at work. I wanted to see.
Oh, my God.
Yeah.
Well, no waste your money now.
Should excuse me.
No waste your money. It's a little like, what was it, Rogue One? Was that a Star Wars movie?
I didn't watch that one. That should have told me before I said
I
it.
mean, there was a soul alive at the end of the movie. They were all
You
dead.
know what some people
I was like, what?
You were like,
That was
okay,
some
nobody
people
said
that
anything.
I was writing down.
Like, y'all just sat there. He said, because anyway, not want me to say it, so don't ruin it. What was we talking about?
Huh?
Wasn't Black Panther in that one?
Yeah, he died.
Oh, what the heck? Come on, man.
Bro,
Oh, it's spoiler like
Come on.
I'm about to hit you.
that. I like spoilers.
Come
I'll be
on.
mad when I'm listening. Black Panther good. Right. I'm just like that.
Yeah,
I didn't know. I didn't want to know.
it's sort of all over the place. They got
It's my baby in it. Oh, my God.
All right. Before, two more people have a meltdown about the ending, let's flush Tomas and move on. All right. So we're going to talk, first of all, about kinetic molecular theory. Now, let me refresh before you take the test tomorrow. Okay? What is kinetic molecular theory again?
KMT.
That was not what I was hoping for.
Oh.
Oh,
What is the question you're going to say on the test tomorrow?
Particles have movement.
What particles?
All particles.
Okay.
I said
All particles have motion. So when I say all particles have motion, what states am I referring to? All right. So nobody's going to get this wrong on the test tomorrow since I'm reviewing this part before you take it, right?
Sure.
That's the only thing I'm gonna remember.
Well, I hope so because it's one of the multiple choice questions. For God's sakes. You shouldn't get that wrong when I review it with you the day before. Now, when does motion stop?
Never.
Absolute zero.
Oh, really?
Yep.
I thought you wanted
What's absolute?
Oh, I never watched. I told you I was gonna go once.
This is why I go over this stuff again. We talked about this when we did kinetic molecular theory. So, stop talking about the movie. So, what is absolute zero? Okay, put your phone down.
No both.
Zero in the Kelvin scale. Okay? Now, everything that we're talking about on this board was the beginning of the gas laws.
It's like ice.
Okay? No, it's not ice. Okay? Ice is 32 degrees
It's
Fahrenheit.
It's like this. Look.
Yeah. All right?
It's like when you chew meat gum and
That would be negative 273 degrees Celsius or negative 457 degrees Fahrenheit. It's a little chillier than as Andy is imitating over there.
It's like when you chew meat gum and then you drink cold water.
Okay.
That's negative.
Okay, geniuses.
Sometimes
Wow.
she's just like, okay.
Now, given that solids, liquids, and gases all have motion until you reach absolute zero, and I'm pretty certain we can all agree, with the exception of those two, that we are not at absolute zero in this room, that on the atom level, that all of the particles in matter have motion. Okay? Now, if they all have motion, we need to talk about what kind of motion they have. I don't want to know what you know at the moment. So hush.
So,
Now, has everyone caught up?
No. Yes.
Tell me when you have.
Are we almost done with like learning everything?
Yeah. Not even in the ballpark.
Look,
Well, how
we
we
need it to
supposed
be
to know
because
this wall?
What?
Like, we have exams and, like, how much more subjects do we have to go? Because we learn about like 3 every day.
We have a ways.
that's why. Look, I don't got that much room.
Then buy more paper.
Right. I had to move to a binder because my notebook was
All
gone.
right, you there,
I'm
Jaden?
gonna have to do that.
All right. So if you consider what you guys remember about gases, okay? You know that at some point actually, let me not draw them that small. Y'all will all be asking me or telling me stupid stuff because I drew the particles wrong.
Let's just see. Let's just see.
Now, I'm trying to draw these the same size as the gas particles. I don't know if I'm doing a good job, but I'm trying not to make them any smaller or any bigger. I know. Do they look like about the same size as the ones I drew for gas?
No. I mean, yeah.
Yes.
Yeah.
Small.
Now, for the solid, I'm not going to fill the whole box, or we'll be here the rest of the class period.
So you're saying that there's more circles.
I'm trying to show that they're the same size.
But there's more.
There will be more in a solid than in a gas, yes, inside the space. Okay, because I'm going to refer to these pictures. Now, these pictures should not be new. You should have seen these before in other science classes, all right? Because we're going to refer to them as we define a solid, a liquid, and a gas.
Why'd you fill up the whole space?
Because I was lazy.
So it's actually like that, like filling up.
Yeah, it would fill the whole space. I just quit because I was tired. Here, hold on. I can make it better.
You better just erase that part and then.
Huh? So gases have less particles,
Gases have a lot more space between the particles.
so they get to move around.
Yes. While it's running through my head, how many days will I be here this week for tutoring or makeup work?
None.
I'll be here twice.
Oh,
Okay, what days will I be here? Anybody remember?
Tuesday and Thursday.
Tuesday and Thursday, very good. Now, if you have missing work, and there's some of you who do, next week, the only day I can stay is Wednesday, okay? Now, with that said, we're approaching the end of the semester.
That's crazy.
I know, it does seem crazy as well, but we're getting there rapidly. Some of you will wait to the last minute and then be like, my work schedule this fall, I can't. Or this, I can't be here that day. If you know that you have a busy schedule, do not wait to the last minute to make up makeup work. I will not work with you. I know that sounds harsh. Last week I was here 4 days. I have been here many afternoons by myself. Okay? If you have missing work, get it made up. Don't keep pushing it out. Darlene came last, what was it, Thursday, Wednesday? What day did you come to make up that test? What? Thursday. It's been how many weeks since we took that test? At least 4. What do you remember on that test? It was bad, wasn't it? Yeah. If you don't know it, either you're going to have to take a 0 or at least come take it or try and see if you can get some points. Some points are better than no points. But keep pushing it out and pushing it out. You are not going to do better waiting. Okay? And I'm not picking on Darlene. I only asked her to illustrate that you forget over time. Okay? You just forget. That's the nature of what we're doing. The exam questions will be more generic and more sort of global about the course. My 65 question test, was it global about the course?
Yeah.
No, it was very direct about that topic. Okay? If I was making an exam, it would be more global about the course. Okay? I think it was Stephanie who came and took a quiz, and she was like, well, I don't remember this stuff. I don't even know how to do it. And it had only been 2 weeks. It happens to everybody. Come make up your work, okay? Now, when you look at these pictures, what kinds of things do I want you to know about solids, liquids, and gases? I want you to be able to tell me about their arrangement, and I'm going to make a chart of this, so you might want to wait until I finish writing. Their arrangement, their motion, and their attractive forces. And we want to do this for solids. Let me do gases first because we've already studied those. That should be an easy one. For liquids and for solids. Okay. Now, based on those pictures and what we know about the three states of matter from our own experiences from our other science classes, we should be able to describe the arrangement, the motion, and the attractive forces of solids, liquids, and gases. Now, when I say attractive forces, does anybody remember what I mean when I say that?
Like magnets?
Sort of like magnets. So what forces did we talk about that were like magnets?
Oh, yeah.
Like what?
Like what Andy said?
I didn't hear what Andy said.
Electrons?
Nope.
You wrong.
Electrons repel each other.
You double wrong. Oh, protons and electrons.
Mm-mm. Think bonding. When we talked about covalent molecules, how do they stick together? They were not glued together. Try giving me a real answer that makes sense.
Zero.
You remember anything about dipole?
No.
You remember the other names that went with it?
Oh, no.
I just heard of it.
You heard of it. All right. When I talk about attractive forces, I'm talking about dipole, London dispersion forces, and hydrogen bonding. Okay, those are the ones I'm talking about. All right, you are supposed to know that dipole is a polar molecule that attracts another polar molecule. You're supposed to remember that London dispersion is a nonpolar bonded to a nonpolar,
You don't remember that.
and hydrogen is a hydrogen and a lone pair.
Is that gonna be on the exam?
It's entirely possible. Remember, I don't ever see the exam. I've not seen the exam in more than 5 years. Dipole.
Tomas, oh my God.
He's trying to be funny today. Unfortunately, it's
He
not
was
funny.
serious.
No, I was serious.
Okay.
I didn't see that. Oh.
It's dipole. Now, gases. How are gases arranged? Look at your pictures on your paper. How are they arranged?
Just spray out.
Okay? They have absolutely no arrangement and they're far apart. All right?
Hey, don't take that from me. Let me keep you.
Okay? Now, if they're very far, whoops, look my R off. Let me fix that. All right, so if there's no arrangement and they're very far apart, what can you tell me about their motion?
They can move around a lot.
Okay, so would they be the fastest moving of the three or the slowest?
Fast.
Okay, they're the fastest moving of the three. All right, now, do you remember the three kinds of motion we talked about?
Vibration.
Okay, so if I cruise back over here, all right, we had vibrational motion. What was another one?
Translation.
Translational.
Rotation.
Very good. And rotational. And rotational. All right, which one of these do gases have? I have all three. Very good. Okay, so they have all three types of motion.
Oh, vibrational, rotational, what?
And translational. You mean to go back?
That means they're like.
Yes, they can move anywhere throughout the container in a straight line. Okay? They can also spin, and they can also vibrate. They can do all three things. Now, they can move the easiest because their particles are far apart. It's sort of like right now, if I sent one of you up the main hall to the office, you would be able to move pretty easily. There might be some people in the main hall, but are there going to be a bunch of them? No, you could easily go up and down the main hall pretty easily. Now, would there be attractive forces in gases?
No.
No, okay? These are going to be the weakest, and they're the weakest because the molecules are far apart and fast moving. Okay? So if they're far apart and fast moving, can they stick and attract each other? No. Okay? Everybody with me on that?
Yeah.
So how is a liquid different in comparison to a gas?
Has attractive force.
Okay? It will have attractive forces. Okay? So they're stronger than a gas. Are they going to be stronger than a solid? Okay, so weaker than a solid. Okay, so stronger than a gas, weaker than a solid.
Anything else on that box?
No. Now, liquids would be like going up the hall during class change. Okay? They can move around. Is it easy to move around? No. They're going to bump into people, but you can move. So, what can you tell me about liquids? Are they fast moving or slow moving? They're going to be slow moving. Lots of molecules in the way. Okay? There's lots of molecules in the way of a liquid. Think of the main hall when there's a lot of people there. Think of it like after a fight and you're trying to get up and down the hallway.
Fire.
Or fire. Now, what kind of motion does a liquid have? Let me extend my box here. Okay. Does it have any other kind?
Yes.
It vibrates? Translates? Yeah. Okay. All three types of motion. Okay. Has all three types of motion. No. They don't.
They can't work.
Nope, they can't. I can't translate either. Are you kidding me? I swear I'm sweating. Maybe I'm going through the change. I'm having a hot flash, don't recognize
You want
it.
my jacket? You want my jacket? Please. Is it a zip up? Yes.
I have a mine.
Y'all need to start bringing a coat or something.
I was, but I was like, it's gonna be okay today, but.
All right, the arrangement. What can you tell me about the arrangements of liquids compared to gases?
They're the same.
Okay, is there an arrangement?
No.
No, but they're what?
Closer together.
They're closer together. All right, so there's no arrangement. But they're much closer together. All right, so the last one we have is the solid and how it compares to the three. All right, so tell me about a solid. What would its arrangement look like compared to a...
Got no arrangement.
Side by side.
It does.
All right, solids have a fixed geometric pattern.
Do we ever remember that?
Mm-hmm.
Wait, so they're like in perfect shape.
Yep.
Oh, that's really cool.
have a crystal lattice. I'm gonna look out here without getting hit by a speeder.
I didn't know what you called it.
A speeder. It's a spider. My son hates them. He calls them speeders.
I thought you was talking about that the other day.
I was raging on.
He weighs like 250 pounds and he's 5'8", 5'9", and he hates spiders. And you want to see him move? Let him see one. I mean to tell you, everybody got
What grade is
it?
your daughter in?
She's a 10th grader.
Oh, never mind. I was about to ask her. Is she go to prom?
Yeah, this weekend.
With who? Habu?
No, a friend of hers. They're just good friends. He wants to date, but she firmly says no.
Friend zone. Hey.
All right.
He's gonna put this ring.
Yeah, it's driving him nuts too. All right. So
Focus.
these are, remember back in bonding when I told you there were 7 crystal structures and I'd show them to you when we got here? All right, you do not ever have to know the names. Okay, I'm never going to make you memorize the names. However, there are 3 of them I am going to make you know.
What? What?
What?
You just said me. Don't say that.
There are 3 that you have to know. They're all cubic. 2 are cubic and 1 is 1 over. All right, so there are 7 crystal structures. Cubic, and where's the other one I want you to know? Hexagonal. All right? Now, those are just examples, but solids have to fit in one of these structures, okay? Which is why I said you had to know they're a fixed geometric pattern. Now, the reason I point this out,
Said cubic, which was hexagonal, which was the other one?
the one that says hexagonal, yeah.
No, I said cubic, hexagonal, which one?
Just 2 of them are cubic and 1 of them's hexagonal.
Okay.
All right, so if that's not what I meant to do. Stupid. All right, close that. Pull that back. And because Xavier is dying to know,
I'm not.
Xavier wants to know, all right, for the solids, and we're going to talk about this hopefully when we get down here. All right, solids that you have to know. All right, cubic crystals that you should know already, salt, and sugar. And if you actually look at these and spend any time looking at them, both of those are pretty obvious when you look at them.
Where did that go under your?
Just put them under your charts right now. I'm going to talk about them again if we actually get to solids at the end of class, but they might roll over into Wednesday. All right, and the second one that I want to talk about is hexagonal. Hexagonal is ice. You remember how many of you have put anything in the freezer and it's either cracked the container it's been in, broke the cap, caused it to leak the next day?
Never had that.
You never had that? Really?
Absolutely zero.
Nah. When you put a soda can in it.
Okay.
You can put a soda in the freezer.
Huh?
You can put a soda in the freezer.
Yes, same thing. All right, when you freeze water, okay, water freezes in this pattern and it traps air in the center. All right, and because air gets trapped in the center of the crystal, all right, it causes the ice or the water when it becomes ice to expand. Okay, and because it expands when it freezes in that crystal structure and air gets trapped inside the crystal, if you have a plastic bottle or a 2-liter or, you know, whatever it is you stuck in the freezer, you've got to suck some of the water out or drink some of it. Or, you know, I was always putting Kool-Aid in something. If I wanted to go out the next day, it was going to be hot and I wanted it frozen so that it would melt throughout the day and I'd have a cool drink. That way I didn't have to carry a cooler or something. I'd have a cool Kool-Aid or something to drink throughout the day. I didn't want a carbonated beverage back in the day before I got hooked on Pepsis. So I would take Kool-Aid and freeze it, and then I had to make sure I drank some out of the top so it didn't split my bottle if I put too much in it. Because air freezes inside of the crystal, causes the ice to expand. Tomas.
Why was stuff back when you heat it up?
Most things can't handle the extreme temperature change. Okay?
Like glass.
Yes, like glass, it can't handle it. Pyrex can handle more of an extreme temperature change, but even the Pyrex that I have in here, you can't do but so much to it. All right, so to finish this up, I did because he's probably going to do something dumb. All right, so motion. What kind of motion does solids have? We just talked about it.
Slow.
It's slow, yes. And what else?
It vibrate.
It vibrates only. Okay? It vibrates only. And the last box, what can you tell me about the attractive forces?
They are the strongest.
They're the strongest. Why would these be the strongest?
Because they don't move, but they stick together easily.
Okay? They're the closest. Okay? So they can attract the easiest. Okay? But the fact that they're the closest allows them to attract the best.
You got the other page real quick.
What? This one? I will after y'all get that. You mean the one after this one? With the crystal things? Yeah. All right, does everybody have what they need here? Because Xavier needs me to go to the next page. All right, let Xavier get that, and then.
I'm done.
Matter of fact, I'm going to soak ahead of you. So I can cool down since I'm hot. And y'all
I'm hot.
I'm hot.
It feels good in here.
Hot. Right.
Apparently I'm working much harder
We
than
at
y'all are.
absolute zero.
We need to be a little closer to freezing.
No, but. As hot as it is.
What, bruh? What, bruh? Is it a problem, bruh?
Shut up,
Problem,
bro.
bruh?
Shut up, bro.
Oh,
bro. Yeah, jump, bro. Busting.
Go.
They need her permission to do it.
You done?
Hey, count how many people we have here.
Huh?
Count how many people we have.
7, 22, 18. Count. One number.
15.
David's wearing khakis today. Don't forget to count through the right here. Andy.
All right. Does everybody have a paper? How many did we have, Xavier? 15. All right, so I have one odd number. So, Baden usually prefers to work by himself instead of a group. Do you still wish to do that? Or do you actually want to work with a person today?
Doesn't matter.
Okay.
As long
Huh?
as it gets done.
Okay. Baden can work in a group of 3. Okay? That's fine. You can work with your group. So, everybody else is in a group of 2. Why are you wearing jeans that look like a raccoon HV's out?
Oh, she was.
Across the street the other day, and it was so fat. It was moving so slow. And I was just mad. It said,
Voice really got it right.
it was so slow.
I mean, you want to go to Spot Closet and get that fixed. That's not even in the ballpark spot.
Oh,
What? With the knees down.
Yeah.
It does.
And they're like great. And they're great.
Right.
You wear these out of your jeans every day. Yes, it does.
There's Jane written all over right there.
I used to see him every day. That's the only reason
And
I
they're
wear
great.
them. Not every day.
All right, look.
And
Let's
they're
put them on
great.
You don't wear those back. And the next time you have them on, I expect you to rat him out.
Deal.
Y'all stop wearing jeans that look like squirrels, but in there chewing on your pant legs.
You think those are bad? One girl just here before it's time to.
I mean, that's pretty blatant.
Somebody had holes in their pants for
Yeah, my instruction was a little bit kissy.
I would.
I mean, it wasn't even like that. Like they were holes all the way up to the top and then all the way down to the bottom. The shoes.
Okay. Leave it be. All right. So what I want you to do All right, a lot of these words you guys know. All right, if you find a word that you don't know, use your cellular device to look up what the word means, to put it in the right column. Okay, so some of these words are going to fit in more than one column. All right, but this is something we can do pretty quickly. I'm going to give you 10 minutes or less. If everybody's done less than 10 minutes, then we'll move on and discuss them in under 10 minutes. Okay. If you need longer, then we'll talk, but I don't think we'll need more than 10 minutes, okay? So find a partner, put them where they go, and then we'll see where we're at, okay? Quickly, while I grab the stuff we need for the demo.
Yeah, but you fake anyway.
Oh, wow. You gonna help?
Yeah, cause he a fake.
How, right? That was not my fault.
We should do that. I said go at 8. I go to sleep early sleep. I can't stay up late. He was just like, hey, what's the latest? He said, I said 10. Then let's go with the one at 9 because I'm gonna be asleep. While asleep in the movie. He texts me, I'm at the movies waiting for him. I'm just like, they're not gonna show up. It's 9 o'clock. He ain't text me yet that he can't come. So I'm at the movies wasting gas because you didn't come.
I don't care. I live downtown.
Miss Wall.
Babe, you gonna go over there and work with Darlene? I'm gonna work with Darlene and Tiffany. Hey, you two get to work over there. Gas is no.
It's your liquid and solid. Okay, I have a question. You put that on the liquid or solid? Because liquids, when they freeze, they expand, but if they're just a liquid, then they don't.
You liquids, sliding cells expand, not frozen, just liquids.
Yeah.
Then don't put it there at all.
I mean,
I think
Yes, so those will go in one place.
I don't know
That would be solid.
It says liquid little. Oh, that's Well, Miss Wall, are liquids considered liquids from the Cresco? Because it says that they have little flexibility. But they are.
They would be the ones who said
It doesn't say, it says relative flexibility.
that would be liquid.
That would go under.
No, they already did it.
You gotta do it. You gotta do the lab.
Yeah, I'm going to do a specific thing. I don't know, I need to check to see if there's anything in the AP class. The AP classes are not or which day. I can't do it before. On Wednesday, there's no way to talk it Wednesday. Thursday, Friday, or early next week. When I was doing this, like, It's a matter of time. I feel like you're right, that I'm not. I'm not even that. I think you're right.
I think it is.
Yeah, good.
I mean, all of them is transformed. You get the whole class through for the test? He said, all things matter to them when he was what are we talking about?
Just sitting there.
We can all go to the
But I think the next one. It's gonna be that close, this close.
What
But I
time?
don't know, I like this. Everybody else really good.
All right, we done?
I broke our hearts.
We want to see it.
You don't know what it is?
Close.
So, but you not telling me.
Hurry up.
And if I put it, maybe just on my side, it's on my side. And that's on my ribs, that's hurts. Like, ready? This one didn't hurt. Cause I expected it to hurt, and then he was like, "You gonna feel it?" And it literally took me probably less than 2 hours. He went over it, and he traced it again, and he went back. Yeah, he missed a spot. But it didn't hurt. It hurt more after it started sleeping. I was like, no, that same day, I remember it was like 3 hours after I had my braces on, I tried to bite into McDonald's. It hurt so bad. I could not eat it. I played on my birthday. Right. Cause you know how everybody's and I was the next one, I was gonna get roasted when I was on my shoulder. But afterwards, she got a roast. And I want to get roasted after she got roasted. Major key. Did you hear you are good? Oh.
She will, don't lie.
That's all.
Alright, if you will, move back to your seat so we can see what you came up with. Alright, let's see what you came up with. Move back for me.
Yeah, that would be a lot.
Oh, can I get some water real quick?
Yeah, I came back.
Miss Wall, what is S in you?
What is what?
Hey.
Do I have context?
Like a call.
Southern Methodist? Alright. So, I gave you some properties that we should be able to put in the right place. Now, some of them were from the gases that we just studied. that are on your test tomorrow. So that helps us review for what's in the multiple choice section of the test. So I'm going to make 3, sorry. I hope that wasn't a calculator that just hit the floor. Gas first is that's the first column. Liquid next is that's the middle column. And solid last says that's the third column on the chart. All right, so for gas, what'd you put in the gas column?
Fluidity.
All right, let's do it this way or I'll forget what's on this paper. Let's start with fluidity at the top. Where did we put fluidity?
Gas and liquid.
Okay, I like that. All right, fluidity fits here with gas and liquid. So if you don't have fluidity in both of those spots, put it there. Now, you already have this defined for the test bar. So somebody refresh our memory on what that is since it could be on the test bar.
That means you can move.
Okay, you can move through it. It's the ability to flow or to move throughout. Okay, the particles fit this picture right here. So the particles can move and scooch around wherever they want to go, right? All right, the second property we had up there was what?
Low density.
Low density. Which one would have the low density? Gas, okay? Why would the gas have the low density? It had the small mass and the large what? Volume. Okay, and in math class, if you have the small mass on top and the large volume, what happens when you divide by that large volume on the bottom? You get a small number. All right. The next one, evaporation. Who can evaporate?
Liquid.
Liquids only. Liquids evaporate. We're going to talk about this when we do state changes. Okay? Evaporation is a state change. Okay? It changes from a liquid to a gas. Now, because I'm going to say this multiple times, and I'm going to have to do it multiple times, I need to point out that evaporation has to be a non-boiling liquid. Just like earlier when we talked about absolute zero and that first slide about KMT, and many of you did not remember, I want to point out evaporation applies to a non-boiling liquid. So when you go home and you put a pan of water on the stove and you heat it too long and all the water is gone and you come in and say, Ms. Wall, water evaporated out. I know what you're talking about. But if that water was boiling, did it evaporate?
No.
No, the correct word would be it vaporized. Okay? It rains, and the court's dry for Andy to play tennis later today. Did that water boil off the courts? That evaporated. Okay? But when we use the word evaporation, it has to be non-boiling. Okay? And I will repeat that over and over after we talk about phase changes tomorrow. Or not tomorrow, Wednesday.
What does it mean to evaporate?
Evaporate means to change from a liquid to a gas.
Yeah.
Okay.
This Thornhill showed me some kind of liquid. It's like it had like this tube, and then it had two sides like this, like with a ball on it, and then like.
Yes, it has a low boiling point so that you can get it to evaporate fast. What it is, I don't know off the top of my head. My guess is it's an alcohol of some type.
What's the difference between evaporation and evaporation? Yeah, vaporizing.
And vaporizing just, it's a more encompassing word. So when we talk about vaporizing, I will put subcategories of evaporation and boiling there. And we'll talk about the differences between evaporation and boiling. Okay, boiling has to take place when you reach atmospheric pressure in the room. You don't boil until equilibrium vapor pressure equals atmospheric pressure. There's a whole set of circumstances you got to have to boil. Okay, evaporation can happen at a range of temperatures. Boiling happens at one temperature. Okay, that's the biggest difference between evaporation and boiling. Okay, evaporation could be at any temperature. Boiling is at one temperature. You okay over there?
Sure.
All right, what's next? Compressible. Who's compressible?
Gas.
Gas is compressible.
Just gas.
Just gas. Okay? All right, you stink. I can't keep saying.
What do you have?
Means it can be squished and pushed together.
What do you say?
What? Isopropyl alcohol. But it's 100 proof, so I'm tired of sniffing it. Freezing. Who freezes?
Liquid.
Liquids freeze. Freezing changes from a liquid to a solid. And again, we'll talk about these Wednesday when we get to phase changes, because when I put that on the board, that was a pipe dream. All right, who has definite shape? Solid has definite shape. What's the next one? Who has definite volume? Nope.
Solid and liquid.
All right, definite volume is a solid and a liquid. Because a gas will take the shape of whatever container it's in. Okay? It will take the shape of whatever container it's in. All right, so definite melting point. Solid. Which one did I skip?
Yeah.
All right, who's relatively incompressible? That's liquid, okay? Now, several people will argue with me that we can compress a liquid because if I look back at the picture, there's a tiny bit of space between the liquid particles. Yes, there is an itty-bitty amount of space, and truly, my picture is probably exaggerated a little bit with the amount of space that liquids have, just so you understand there is some space, because if I drew it the way it really is, there would be so little space, you would be like, that's a solid, Miss Wall. So I have to illustrate some space so that you understand they're close, but they're able to move. However, for the purposes of liquids versus solids, liquids are pretty much incompressible. You can't really put those particles any closer together, okay? So they're relatively incompressible. All right, surface tension. This one I expected most of you have to look up. Liquids have surface tension, and that's what all this crap on the floor is for. If we have time for me to demonstrate surface tension.
That's like when something coming up out of the water and it hasn't broken the.
Mm-hmm. Yep. And all right, so let's define that. Since some of you probably didn't write down the definition. What is surface tension? It's a force that holds adjacent molecules together. So if you have a flat counter, wax paper, something, you'll see beading of water like that, okay? And that's why I got out the overhead projector and the alcohol, because you can demonstrate that with alcohol and water beautifully. It worked really well when I had the old smartboard. It doesn't work quite as well on this one. H2O. Mm-hmm. All right, what have we got left? High density. Who has a high density?
Solid.
Solid. All right. Expansion. Who can expand? Gas. Okay. Diffusion. All of them.
All of them?
Yep. Now, because all of them can, who would be the fastest? Gas. Okay. So beside diffusion, I'm going to write fastest out here beside it. All right. Why is the gas going to be able to diffuse the fastest? That's right. There's more room. It's a lot like going up and down the main hall, like my example earlier.
How does a solid diffuse?
I'll get to that in just a second. All right. So this one, I'm going to put middle speed. All right. Everybody okay with liquid before I turn it? And then solid would obviously be the slowest. Now, this one would take, when I say slowest, I mean years, okay? So if you took two metals, let's say zinc, which is a silver color, and copper, which is, y'all know copper, sort of a brownish, reddish brown color, and you C-clamp them together so they were nice and tight and you left them for 20 years, they would eventually bleed into one another. It might take 20 years. It's going to take a long time. You can't, put them together for a year and get it to happen. It would take years for them to diffuse, but eventually they would. All right, who's not compressible at all? Solids. All right, and the last one was middle density. Who had the middle density? Yep. All right, everybody okay with what went where? All right, so the last thing I want to get to before I have time for the demo is the two kinds of solids. If we get that done, I'll feel good about where we got today. If I'm not mistaken. I'll make sure I got everything. Yep. Because I can always do the demo on Wednesday if I have to. All right. Two types of solids. All right, so the two types of solids. Number one is crystalline.
Is this a different subject?
It still goes with solids, liquids, and gases because this is two types of solids. And amorphous. All right, so a crystalline solid is a solid and has a fixed geometric pattern and it has a definite melting point. An amorphous solid, and this is pronounced more, that's an F sound, fuss solid. Okay, amorphous. Don't tell me is that a word. I'll sound like a bunch of illiterate fools. I want you to be able to pronounce it. Amorphous. All right? This one is a solid with a random pattern and it melts over a range of temperatures. Yes, I'm going to give examples. Just where I'm going to catch up.
That's PHSUS.
PHOUS. So it's pronounced A more, and PH has an F sound. So amorphous.
You really have a lot of people who don't know how to say it.
Yes, I do. They tell me that A word all the time. It drives me nuts. Amorphous.
Oh, that's what they say.
Yeah, that A word.
They didn't even try.
No, they didn't.
Amorphous.
Huh?
Amorphous.
Amorphous. I mean, it's not that hard. Like, if I was
Right,
it, I would say it
right.
like
I
that.
don't see any other way that you can.
You'd be surprised.
That's like that teacher, he called Emma Ema.
He calls her what?
Ema. Yeah.
Ema.
Yeah, he's like, hey, Ema. Yeah. Her name is
Did he
Emma.
watch YouTube and jack up all those names like that dude there?
No, he got everybody's names right. He was getting even the crazy names, but then when it comes to Emma,
He
he
said
said
Ema.
Ema.
Who was it?
That little black man, his skin.
Mr. Warlock.
Not that.
Really?
Mr. Wade.
Mr. Wade went on.
Wow.
Oh.
It was funny.
Oh,
I remember now.
So, some crystalline solids. What are some crystalline solids? Can you give me anything you think is crystalline?
Crystal.
Salt, sugar.
Salt and sugar.
You gave it to us.
I did.
Salt. David, that was probably the best answer you've given all
Right.
semester.
That's what I was thinking.
All right, ice. All of those are going to be crystalline. All right, marble. Those of you who like diamonds. Any of those would be crystals. All right, so what's amorphous? Has a random pattern. It's going to melt over a range of temperatures.
Let's see.
Ice is crystalline.
Wood?
Not really.
I think about the patterns in it.
Glass.
Wait, it's plastic?
What things do y'all use in the
Randy?
house? What?
Randy?
Who melts plastic?
Only people who accidentally stick it on stuff. I melted it on the grill yesterday by accident. I got the plastic bag too close. Okay? Any of those things are going to be
What is
amorphous.
fiber optics?
Anything.
Fiberglass?
Yep. Or have you ever seen those like Christmas trees or decorations that have those lights that change colors at the holidays? That would be fiber optics also. It's in all cable and phone lines.
How does a random pattern work?
How does a what?
A random pattern work.
A random pattern work? It's sort of poured into a mold. Okay, it's not going to be crystalline like those structures. Remember, it's a crystal lattice, so it's got a repeating unit cell. This is not going to have a repeating cell or pattern.
Does it make all these things?
Yeah.
So they're not like natural?
No.
Okay.
Well, they can be, but most of them are not going to have a repeating unit cell. You know how the
What they say? Fiber optics.
But you know the unit cells that I showed you here, like the cube, and the cubes kept repeating? Those are not going to have anything that repeats. It's all completely random. Now, what's our homework tonight with our 5 minutes left? Because I don't have time to do the demo. I'd spend more time trying to adjust that thing and tape paper to the smartboard. I'll try to do it. Remind me because I'll leave it out on Wednesday and start a class. Okay? Now, you need to study. Like I said, it could be your last test. Hopefully it won't be. We're going to do a lab on specific heat. I'm not going to do the salt lab. We're going to do the specific heat lab.
That lab fun.
I don't know.
Is the salt lab fun?
Most of you would have liked it better, but you would dislike the lab report. So I'm picking one that will be easier to do the lab report.
yeah, my lab report was trash.
So that's why I have elected to do this lab report, given we're in the middle of AP exams, and a lot of you won't be doing AP exams. So that's the reasoning for the specific heat lab. All right, when Sophie puts her calculator up, I need one more. Whoever's got it.
That makes me laugh.
You won't do it and then leave your
I mean,
receipt.
obviously.
Do it and then leave the receipt. That makes sense.
I don't know where they come from.
I saw it.
You gotta send it.